This is your Chapter 8 review. I'm going to go probably pretty quickly through the questions, but you can always re-watch any section that you need to watch again or watch the video of what I'm doing with each of the problems. So in Lesson 8.1, we learned to factor each monomial completely, meaning that we pull each part into its most basic prime parts. In order to do that, we do a factor tree. Some of you can do it in your head, but I'd like to show visually on the video. So I know it's even, and I always like to take out any even numbers that I can. 2 is the only even prime number, so I take out a 2, and it's 2 times 75. Then 75 breaks down into 3 times 25. Let's try to do my smallest number first, and then 25 breaks into 5 and 5. So now that I've got all of my prime factors, which would be 2 times 3 times 5 times 5, all I do is I write down 2 times 3 times 5 times 5. And then to break down my variables, remember, it's just writing down how many of those are being multiplied. Well, there's 2 g's being multiplied, and there's 3 h's because it's h times h times h. And that is the prime factorization of number 1. Number 2, the only real difference here is, remember, when you've got a negative, you've got to pull that -1 out first. So it's -1 times 72. And now it goes just like we did over here. So 72 is an even number. So I'm going to break that down into 2 and 36. I circle 2 because it's a prime number. 36 breaks down into 2 and 18. So that, again, is a prime number. 18 breaks down into 2 times 9. 2 is a prime number. And then 9 is 3 times 3. And so my prime factorization of this monomial right here is -1 times 2 times 2 times 2 times 3 times 3 times m times n 4 times. So times n times n times n times n. And that's all it's asking you for. It just wants you to break it down. If any of these numbers can still be broken down, like if I say a 6 in there or an 8, it is not factored completely. Okay? So section 8.2, now you had to find the GCF. Well, we used that information in the last one to find the GCF. Now on this one, I'm going to go ahead and do it the long way where we circle. On the second one, I'm not. I'm going to kind of talk you through it. That way you have one of both ways, but you could definitely do the way that we're doing on the first way on the second one. So I'm going to break down 18. 18 breaks down into 2 and 9. 2 is a prime number. 9 breaks down into 3 and 3, both prime numbers. Okay, so that one's broken down. So 18 AC squared breaks down into 2 times 3 times 3 times A times C times C. Okay, and not so pretty, but functional. Then the second one, let me get a different color. So 54 breaks down into 2 and 27. Perfectly. Then 27 breaks down into 3 and 9. And then 9 breaks down into 3 and 3. Okay. And so then, let's see here, 54 a to the third c squared is 2 times 3 times 3 times 3 times A times A times A times C times C. So we broke down, we did like we did in 8.1. Now for 8.2, we're just looking for what they have in common. So I'm going to pull a third color in here. And I'm going to circle everything they have in common. So they both have a 2 in common. They both have a 3 in common. They have another 3 in common. They both have an A in common. And then they both have at least one C in common. So I'm going to go ahead and grab those. Remember, they don't have to be right underneath each other for them to be in common. But then I take those numbers. So there's 1, 2 in common. There's a 3 in common, another 3 in common, an A in common, and a C in common. And in fact, I missed a C. I can see the way that I did this. So, and it's okay. Watch this. That's another one. We're just going to circle those together. Okay? So there's another group. That's C times C. So the GCF here is 2 times 3, which is 6, times 3, which is 18. So it'd be 18AC squared. That's the GCF for those two numbers up here. Okay? Now for 4, I'm not going to do it the same way just because to show you a different way, I can just look at my factors of 60, 48, and 36 and think, okay, what's the highest number that goes into there? And so I think, okay, well, 6 goes into 60, 6 and 10. 6 also goes into 48, and 6 also goes into 36. But there may be a higher number, so let's try 12. Well, 12 times 5 is 60, right? 12 times 4 is 48, and 12 times 3 is 36. Now, I know my factors pretty well, so I can see right away that 12 is going to be a factor of all of these, and then leave a 5, a 4, and a 3, and the 5, 4, and 3 won't have anything in common. So 12 is my biggest number that goes into all 3 of those. So 12. Then I look at how many x's they have in common. So this one has 2 x's being multiplied. This one has 3 x's. This one has 2. So the most I have in common is 2. Okay, because they all don't have 3, but they all have at least 2 being multiplied. Then I have 1 y here, 2 y's being multiplied here, and 2 y's being multiplied here. Well, if I break that all down, they all have at least 1 y. So that would be your GCF right here. So that's 3 and 4. On the next one, it said to use the distributive property to factor each polynomial. Well, this is the time that we find the GCF, and you can find the GCF any way you want to. We've just looked at how to find the GCF, so I'm going to go through that part pretty quickly, but at least you'll see what to do once you have the GCF. So on number 5, the GCF, well, the biggest number that goes into 7 and 14 is 7, right? And then they both share at least 1x. So 7x is my GCF. To find out what's left, you could be using on, like you did on this page, you could say what's left, you know, whatever wasn't included. But if it isn't included like on this one, if everything's circled, remember that there's still a 1 there. But we're just going to divide out. So I'm going to divide out the 7x here. I'm going to divide out the 7x here. And I'm going to write down what's left. So I should have a binomial left of what's in here. 7x squared over 7x. Well, the 7's cancel. One of my x's cancels. So I'm left with x. And negative 14 divided by 7 is negative 2. And the x's cancel. So that's factored. Okay, there's nothing in common here in my 2 binomials, or in my 2 terms in my binomial, and I pulled out my GCF, so done. Okay, for number 6, we're going to do the same thing. What's the highest number that goes into 3, 9, and 6? That would be 3. So I'm going to pull out a 3. They each have at least one s, so I'm pulling out an s. And then I have t squared, t, and t squared, so I can only pull out one t. So all you do under each term is divide by your GCF. So I get 3st, 3s3, st, and 3st. And when I look at what's left, this cancels, the 3 cancels, the s cancels, and one of my t's cancels, so I'm left with t on my first term. Negative 9 divided by 3 is negative 3, right? S to the third over s gives me s squared, and my t's will cancel. And then plus 6 divided by 3 is 2. S squared over s is s, and t squared over t is t. Okay, so that is that one. You just divide out. This is last chapter's work using here, but you divide out your GCF and you get what's left. Again, remember, anytime you want to be double checking to make sure you have it right, you can always redistribute back through and see if you get your original problem. If you do, then you're correct. If you don't, double check your work on your division. Okay, number 7. My GCF between 27 and 9 is 9. Okay, they both don't have any A, so I can't pull out an A from both of them, and they both have at least one B. So 9B is my GCF. I pull out 9B here, or divide. That's what we're doing. And what's left, 27 divided by 9 is 3. A squared B, my B's canceled. Nothing cancels my A squareds because I didn't pull any A's out. Hang on. And then plus, the 9's cancel. B cubed over B is B squared. And again, notice your 2 terms left inside your binomial should have nothing in common. If they still have something in common, that means I didn't take everything out that I should have. Okay, number 8, I've got 3 terms here. The reason I know it's not a trinomial that I'm going to put 2 binomials under is because it's not like in the form of x squared plus an x term plus a y squared or xy term, that sort of thing. I don't see squareds at the 2 ends. I'm looking for my GCF, and my GCF here would be 2. And then they all have at least one m, and they all have at least one n. Okay, so I'm going to divide by 2mn, divide by 2mn, divide by 2mn, each of those terms, and then I write down basically what's left. So 2 divided by 2 is 1, m cubed divided by m is m squared, n squared divided by n is n. Then negative 16 divided by 2 is negative 8, m divided by m is cancels, n squared divided by n is n. 8 divided by 2 is 4, and then m's cancel and n's cancel. Okay, so that's it. That's what you're left with, and you're done. Okay, this cannot be trinomial factored. It can't be done. And then you just pulled out a GCF. Okay, so the next section, this is pretty much everything else in the chapter we've done. And so sometimes you're going to group, sometimes you're going to do just a basic trinomial. And as long as you know, like, kind of go through your steps, I always look for a GCF. I'm looking for a difference of squares. If I have 4 terms, I'm going to group. You just have to know those things. So let's go ahead and get started with number 9. I have 4 terms, so I'm probably going to be grouping. That's what I'm going to be thinking in the back of my head first. However, I am going to look for a GCF. There is no GCF. There's nothing in common they all have. And there's not a difference of squares. There's 4 terms, so I know I'm going to group. So I'm going to go ahead and start by grouping my 2 groups here. And I look for what's in common within the one group. So I'm going to pull out an X. And when I pull out an X, I'm left with X minus Y. And all I did was divide out the GCF. Remember, that is what we just did on those last 4 problems. And you're just doing it here again twice with 2 different ones. So I get X times X minus Y. Remember, use your binomial. This one right here has got to be the binomial I get over here. Okay? So I'm going to go ahead and write it down because I know I have to get that. And so I'm going to use that to find the GCF. So I'm going to divide this one by X. I'm going to divide this one by negative Y. Don't forget that the negative goes with the Y. Well, 2X divided by X is 2, right? Negative 2Y divided by negative Y is also 2. So what's your GCF? 2. That's it. So X plus 2. Now looking at these, your GCF between these 2 problems is right here and right here, right? They both have an X minus Y. So I get X minus Y is one of my factors or binomials. And what's left? Well, if you divide by X minus Y, you're left with X plus 2. And that's it. So that's it. That's your answer right here. Okay? And that's grouping. Done. Let's look at 10. 10 is a basic trinomial. Again, I look for my GCF. There is no GCF. I look to see if it is a difference of squares. It is not a difference of squares. It is a trinomial with a leading coefficient of 1, which is the easiest for me. So I go ahead and put down my 2 binomials. And I know it's going to start with a D because D times D gives me D. Maybe. Okay. Then I know that it has to multiply to be a positive. So I'm going to put my little chart over here. If you want to use the diamond, you certainly can. But it's going to be multiply to be a positive 36. And it's going to have a difference, or it's going to have a sum of negative 12. Okay, so it's got to have a sum of negative 12, which that should tell you something. They both have to be negative to multiply to be a positive. And if they're both negative, that means they're adding to be 12. And I'm going to be a little bit smart here. You can go ahead and list everything if you want to, 1 and 36. But honestly, why would I have to do that when I know that it's probably going to be 6 and 6? That's pretty easy. 6 and 6, so it's going to be negative 6 and negative 6 to be negative 12, right? That's my list. And so it's D minus 6, D minus 6, and then we take one more step to say D minus 6 squared. And that's your answer. That's it. Okay, and if you need to, FOIL it back out. D times D gives me D squared. Negative 6D gives me negative 12D, and negative 6 times negative 6 gives me positive 36. So I know that I'm correct. Okay, let's look down at 11. I'm looking for a GCF. Is there a GCF between 36 and 69? And let's see here. 36 and 169, excuse me. I don't think there is because 169 is not divisible by 3, and so I know that I have a difference of squares, honestly. When I look for my GCF, there isn't one, so then I look, okay, are these perfect squares? Yes, 36 is 6 squared, 169 is 13 squared, so I'm ready to go. This is my difference of squares. I only have 2 terms. So this is 6R and 6R. This is 13 and 13. And then this is the one where we get to say just the 2 binomials, and I put the 6R and the 6R. And then we have 13 and 13. And one's going to be plus and one's got to be minus, because that's what gives us our negative 169. Also, it gives us no middle term because I have negative 13 times 6 R's and positive 13 times 6 R's. So they're going to cancel out. That's why there's no middle term. And then there's no way to put this any simpler than this. So we are done. Okay. And that is a 6, not a B. I know that looks kind of like a B. All right. The next one, number 12. So I look for a GCF. Is there a GCF between 4x squared, 4x, and negative 15? No, there is not. So I look for a difference of squares. It is not a difference of squares. It is a trinomial with a leading coefficient, so that means I'm going to be borrowing it and putting it back, and taking out. So we're going to take our 4 and we're going to multiply it by our 15. I put my 4 out to the side in a circle so I do not forget that I multiplied it. I rewrite. So I get x squared plus 4x minus 60 now, because 15 times 4 is 60. And that's my trinomial. Now it looks like this one, the basic one, where we get to do just the straight factoring, and we'll just have to divide out that 4 in a minute. So we're going to go ahead and find my factors. So I want the product of negative 60 and the difference of 4, so the sum of 4. But remember, I read this like I want the product of 60 with a difference of 4. Well, I can do 1 and 60. I'll go ahead and do it the long way here. 2 and 30. And then 3 and 20. That's a 3. I don't know why it's not wanting to work. And then 4 and 15. 5 and 12. And 6 and 10. And quite honestly, I should see right now that 6 and 10 have a difference of 4, right? So that's going to be my group, and it'll be a negative 6 and a positive 10 because I need more positives. I'm left with 4 positives, so that's what I need. So I get x minus 6 and then x plus 10, excuse me. But I'm not done because I still have this 4 hanging out here. So I'm going to go ahead and divide by 4. I want to show you guys this. Divide by 4. And here's the problem. I cross that out as soon as I've used it, right? But 6 over 4 can reduce. I cannot slide this until I have reduced any kind of fraction to its smallest form before I start trying to slide. So this actually becomes, instead of 6/4, let me get a different color here. Instead of 6/4, I get 3 halves, right? And instead of 10/4, I get 5 halves, because those are each divisible by 2. And your calculator will do that for you if you can't see it. Then that 2 can now get slipped in front of the x, but it cannot do that before then. So I get 2x minus 3 as my first binomial, and my second binomial is 2x plus 5. Okay? So that is my answer to it. I mean, that's it. Done. And to double check, 2x times 2x gives me 4x squared. 2x times 5 gives me 10x. Negative 3 times 2 gives me negative 6. So 10 minus 6 is 4. And then negative 3 times 5 gives me negative 15. So I know I have that one correct. All right, let's look at the next 4. So number 13, I'm looking for a GCF. Guess what I see? A GCF. I get to pull out a 2. I'm left with 4a squared plus a minus 3. Okay, now I need to factor this. So I pulled out a GCF. It's not a difference of squares. I've got a leading coefficient. So I'm going to go ahead and circle that and move it. As soon as I do that, I put my 4 out to the side. Also, don't forget about your 2 hanging out here. I'll show you that in just a minute, because you should notice that if you don't get your original answer back, but a lot of you aren't checking, which is why you missed that GCF out here. So I get a squared plus a minus 12. So I'm looking for products that equal negative 12. That's a P. And has a sum of 1. Positive 1. Well, again, I can go out and do 1 and 12, right? 1 and 12, 2 and 6, 3 and 4, and I'm done. Which one of these has a difference of 1? They're not, I mean, none of these. 1 plus 12 gives me 13. 2 plus 6 gives me 8, and 3 plus 4 gives me 7. So I'm not looking for them to be the same because I multiplied to a negative. One's going to be positive, one's going to be negative. I need more positives. That's what this middle term tells me. And my group that says that is my 3 and my 4. So they've got a difference of 1. So it's got to multiply to be a negative. So one of these has to be positive, one has to be negative. So I'm going to do positive 4 and negative 3. That will leave me with a positive 1 in the middle. And positive, that's what I wanted for my sum. So I get a plus 4 and a minus 3. It doesn't matter which way you do it. If you did a minus 3 times a plus 4, that's the commutative property that allows us to do that. Now we're not done because we have to divide out by the 4 over here. And then we simplify if we can. So 4 over 4 simplifies, doesn't it? It simplifies down into a plus 1. And then this 3/4 is already in simplest form, so the 4 is just going to shift in front of the a. So we get 4a minus 3, and this is our solution. And just to double check, a times 4a gives me 4a squared, and look what I forgot. I did forget it. Don't forget about this GCF up here. I need to get 8a squared, not 4a squared, so I need to make sure to put that GCF right in front, because now a times 4a gives me 4a squared, but then times 2 gives me 8a squared. That's what I need to be getting. So now it is correct as long as you have your GCF out in front. Okay, 14, I see 4 terms, so what should you be thinking? Oh, I have a grouping. But let's double check to make sure there's no GCF. I don't see a GCF with any of these terms, so it is not a difference of squares. I have 4 terms, obviously, so I'm going to go ahead and group. Group. Okay, the highest number that goes into these is 2, and they both share an a. So 2a, when I divide each of these by 2a, I'm left with 2b plus, and if you divide by 2a, what's 2a over 2a? Don't put nothing, it's 1. Don't forget that. Well, I absolutely know that 2b plus 1 has got to be what I get over here. It can no ifs, ands, or buts, okay? So I'm going to divide this one by 2b because it's got the b in it. I'm going to divide this one by 1. Well, negative 6b divided by 2b is negative 3, isn't it? And negative 3 divided by 1 is negative 3. I got the same answer, so that is my GCF that I pulled out of there. So now, what's the same? The 2b plus 1. So I have 2b plus 1. And then my other binomial is 2a minus 3. What's left? And just to double check, 2b times 2a gives me 4ab. 2a times 1 gives me 2a. 2b times negative 3 gives me negative 6b. And 1 times negative 3 gives me negative 3. So I get out all those terms. So that is it by factoring, by grouping. 15. Okay, I look for a GCF. I do not see a GCF here. So since I do not see a GCF, I look for a difference of squares. It's not a difference of squares. And then I see that it's a trinomial with a leading coefficient. So that 6 is going to get moved. And sorry, messing up the other one. But it's going to get moved. So I get 6 out to the end. And I get an n squared minus 11n minus 12. So I'm going to be looking at factors of 12 that have a difference of 11. You should already be thinking in your head what this is. It's not very hard. So your product and your sum is negative 12, so I know my signs have to be different because they're multiplying to be a negative number. The only way we get a negative number is if we have one with a positive and one with a negative. And then I get negative 11 here. So right away, 1 and 12, what do you notice? 1 and 12 have a difference of, what do you know, 11. Okay, well, in order to get negative 11, the 12 has to be negative and the 1 has to be positive. So my two binomials are n plus 1 and n minus 12. Again, you're looking for factors of 12. This is always your product. This is always your sum. Product, sum. Okay? I'm not done because I have to divide out that 6. So we're going to divide out the 6, divide out the 6. And now I cross it out as soon as I've used it. Okay? Let's pick a different color. So we can see. Now I make sure everything is simplified and then I slide. So is this simplified? 1 over 6. Yes, it is. So that 6 can simply slide in. 12 over 6, is that simplified? No, it is not. 12 over 6 becomes 2, right? 2 over 1 or just 2. So now this becomes 6n plus 1, and this becomes n minus 2. So just to double check back into my original, 6n times n gives me 6n squared. 6n times negative 2 gives me negative 12. plus 1 times n gives me plus 1, so I get negative 11n. And then negative 2 times 1 is negative 2, and we're good to go. So that one's done. Number 16, I'm looking for a, not a perfect square, I'm looking for a perfect square because it looks like it, but I'm looking for my GCF first. So when I do that, I do have a GCF, and my GCF is 4. So I'm going to pull out my 4, and I get f squared minus 16. Okay, I still have a perfect square, not a perfect square trinomial. I still have a difference of squares. So if I see a difference of squares, I'm breaking it down. This is a perfect square, this is a perfect square, and it's a difference. So I've got a subtraction sign here. So this breaks down into f and f. This breaks down into 4 and 4. And don't forget your 4 out in front. So I get f plus 4 and f minus 4. Because my signs have to be different because my positive 4 and my negative 4 have to drop out. That's why there's no middle term. F times f gives me f squared. 4 times 4 gives me negative 4 times negative 4, gives me negative 16. And that's factor. That's done. 16. Okay, 17. I'm looking for a GCF. I don't see a GCF. I look for a difference of squares. I don't see a difference of squares. I see that it's a trinomial with a leading coefficient, so that means I'm going to go ahead and circle and move, right? So I put my 2 out to the side, circle it, and I get x squared minus 3x minus 10 when I am done with my rewriting. The product I'm looking for is negative 10, and the sum has got to be negative 3. Remember, when it's multiplying to a negative number, the two signs are going to be different. So 1 and 10, 2 and 5, and that's pretty much it. Well, if I add these together, I'm going to get either 9 or negative 9. It's really a difference here, remember. And then 2 and 5 is going to give me the negative 3. In order to get the negative 3, I need to make the 5 negative and the 2 positive because I need more negatives to make it negative 3. I get x minus 5, x plus 2. But we are not done because we have to divide out the 2 that we multiplied into it just a minute ago. This is simplified. 5 over 2 cannot be simplified any further. 2 over 2 becomes 1, right? So I get 2x minus 5 and x plus 1. 18. Okay, so again, I look for a GCF. No GCF. I look for a difference of squares. I do not see a difference of squares. So I look for a leading coefficient, which I have, and I'm going to multiply it through to the end. So I put my 6 out to the side because I'm going to have to divide that out in a minute. I get x squared plus 7x minus 18. So I'm going to look for factors of 18 that have a difference of 7. That's how I read that. Again, factors of 18 that have a difference of 7. That negative tells me there's going to be a difference here. So my product and my sum, so I get negative 18 and 7. Some of you can already see it. You're getting better at your factors. If you don't, just list them all until you see what you need. So I have 1 and 18, 2 and 9, 3 and 6. Well, 2 and 9 have a difference of 7, so that's the one I'm going to pick. Okay, and I need more positives because that's a bigger number. So the 9 is going to be positive and my 2 is going to be negative. So I get x minus 2 and x plus 9. But I'm not done because I have to divide out that 6. So divide out the 6, divide out the 6, cross it out as soon as you do that. Now I look for how I can reduce it, and I'm going to use this different color just so you can see it. The 2/6 becomes what? 1/3. Okay, don't forget that. You got to reduce. 9/6 becomes 3 over 2. Okay, you got to reduce those. Now I can slide. I cannot slide until I have made sure that everything is simplified. Okay, so my true answer is 3x minus 1 and 2x plus 3. Okay, 19. So I am looking for a GCF. I see no GCF. Then I'm looking for a difference of squares. I don't see a difference of squares. So now I see a trinomial. It has a leading coefficient of 1. So I don't even need to slide anything. I just know to go ahead and put my binomial down. I do x and x, and I'm looking for factors of 10. So again, my product of negative 10, that have a sum of negative 8. All right, there's not many. So it's 1 and 10, And I know they're going to be bigger negatives. So 1 and negative 10, 2 and negative 5, and I'm pretty much done. I'm out, right? I don't have any more factors. Well, do either of those add to be negative 8? Well, no, this will be negative 9, and this will be negative 3. So if they don't work here, if they do not give me the negative 8, this is now prime. The other way you can tell that it's prime is to put this into that b squared minus 4ac, which would be 64 minus 4 times 1 times negative 10, which gives me 104. Well, is 104 a perfect square trinomial? No, or a perfect square? No, 100 is, but not 104. So since that is not a perfect square, it is not factorable, so that's why it is prime. So number 19 is prime. 20, I'm looking for a perfect square, or not a perfect square, I'm looking for a GCF. So number 20, I don't see a GCF here. Then I look for if it is a difference of squares. Well, yes, it is. If my exponents on my two variables are even, it's a perfect square. I don't care if it's 6, 8, 10, whatever, because all you're doing when you square root that is you're dividing it in half. So as long as it's even, I can divide it in half. And 81 is 9 squared, 16 is 4 squared, so I'm good to go. So when I break this down, I get 9x squared, and this is 9x squared. And this one breaks down into 4y squared, oh, that's a square, and 4y squared. And so let's go ahead and rewrite our binomial. So I'm going to get 9x squared plus 4y squared, and then 9x squared minus 4y squared. Okay, and here's where you always have to double check. So if I have something with that big of an exponent, I'm going to suspect that there's probably going to be more than one step. So while this is factored, it can be factored further. It's just like when we did our perfect square, or when we did our prime on monomials. If I said that 18 was just 2 times 9 and said that was the smallest breakdown, you'd be like, no, it's not. It's 2 times 3 times 3, because that 9 could be broken down further. Well, guess what? While this one is prime, this one can be broken down further. And it can be broken down because it is a difference of squares again. 9 and 4 are perfect squares, x squared and y squared. I said as long as the exponent is even and it's a difference, I can still break it down. So now this becomes 3x and 3x. This one becomes 4y and 4y. And so I get 3x plus 4y, and then 3x minus 4y. And then don't forget that you still have this up here that is still part of what I need to multiply to get to the original, 9x squared plus 4y squared. And now this is totally factored because there's nothing in common with these two terms in the binomial, and it's a plus, so that's not a difference of squares. It's a sum of squares, which we don't have anything for. Now 3x plus 4y is broken down in its simplest form, and 3x minus 4y. Okay, last 4 problems. Let's go ahead. Okay, 21, I look for a GCF. I do not see a GCF between 9 and 25, and there's no x. Then I look to see if it's a difference of squares. It is not a difference of squares because it is a plus. Then I look to see if it's a trinomial. Well, it's not a trinomial, so there's nothing else I can do with it. And just by going through my steps, I should know that this is prime. Those of you wanting to break this down and saying, oh, there's a perfect square here and a perfect square here, you are absolutely correct. However, you need to look at the sign here. The sign is a plus, not a minus, so that is not a difference of squares. So let's look at 22. Negative 18 plus 7a plus a squared. The only thing wrong here is that it is not in order for us, so I need to reorder from greatest to least, descending order of my exponents on my variables. And now I notice there's no GCF. It is not a difference of squares, and it is a trinomial, so I'm going to go ahead and put my binomials below because there is no leading coefficient, so I don't have to do anything other than a and a. And I'm looking for the product of negative 18 that has a difference of 7. Remember again, product of 18 that has a difference of positive 7. We're going to do this. And with that, my 2 are going to be 2 and 9. And 9 is going to be positive, 2 is going to be negative, and that gives me a positive 7, doesn't it? Again, you can list them all out, but on our video, I'm just going to go kind of quickly. Tomorrow in class, if you need to ask questions about how do you get your factors, please do. We can go over that, no problem. But in this, since I've already given several examples of that, I feel like I can go pretty quickly to say it's going to be negative 2 and positive 9. So negative 2, positive 9, there's nothing to divide out, there's nothing left. If I want to double check real quick, a times a is a squared, a times 9 is 9a, negative 2 times a is negative 2a, so that gives me 7a, and negative 2 times 9 gives me negative 18. So we have that correct. Okay, 23, what should you be looking for? I'm looking for a GCF. Well, I see that all of them have at least a 2. So I'm going to pull out a 2. It's going to make my numbers smaller for me. So I get 6a cubed plus a squared minus 190, or I'm sorry, not 192a. That will be minus 50 and 46, so 96 minus 96a, and then minus 16. Okay, and that's a 96. Hopefully you're listening to me to see what that is. Okay, so that's a 96a. Now that I see that, I've got 4 terms, so I'm going to be grouping. So we're going to group the first 2, group the last 2, and then we're going to do our GCF. They both have an a squared in common, so I'm going to pull out an a squared, and I am left with 6a, is that right? Yes, 6a, and a squared divided by a squared is 1, so 6a plus 1. This tells me what goes absolutely in this one, so it's 6a plus 1, right? So then I divide this one by 6a, I divide this one by 1. Well, negative 96 divided by 6 is 16, and a over a gives me that, so it's actually negative 16. And negative 16 divided by 1 is negative 16, so I get negative 16. So then 6a plus 1 comes out, and don't forget your 2, so I've got 2 times 6a, came down, plus 1, and then I'm left with a squared minus 16. Always double check your binomials to make sure there's nothing left in common and that there's not a difference of squares. Well, there's nothing in common, that's not a difference. However, if you look here, this one can actually still be factored. So a squared, this is a difference of squares. So this becomes a times a, this becomes 4 times 4, right? And so my final answer here will be 2 times 6a plus 1 times a plus 4 times a minus 4. You just always have to look to make sure everything is in its simplest form and you can't break it down any further. And then 24 is pretty easy. It's a nice one to end on. I look for a GCF, no GCF. Then I look to see if it's perfect squares. X squared is a perfect square, 121 is a perfect square, and it is a difference. So I'm going to go ahead and break those down. I get x and x. I get 11 and 11. So I get x plus 11, x minus 11, and that way when I multiply it back out, x times x gives me x squared. Negative 11x plus 11x gives me 0 x's. That's why I don't have a middle term. And 11 times negative 11 is negative 121. Okay, those are your notes. Make sure you have them completed for class and be ready with any questions by the time you get to class.